Hello friends, welcome to the next session on design of tension members. Now we'll take up design of double members. Design a tie member, stress member, to carry a axial working load of 400 kilonewtons. Use double angles with M20 bolts of property class 10.9. Sketch the details. So ultimate or factor load is 1.5 times 2 working load 600 kilonewtons. Therefore area required. So step 1, area required is equal to factor load into gamma m naught divided by Fy. So factor load is 600 kilonewtons into 10 raised to 3, partial safety factor 1.1 divided by 250. So you have the answer 2640 mm square. Now increase the area by approximately 30%. It means multiply by 1.3. 1.3 into 2640. So you have the answer 3432 mm square. Now from steel tables try 2 ISA 80 by 80 by 2. We have to use 2 ISA because in problem it is given that use double angles. So you have to provide double angles 2 ISA 80 by 80 by 2. So area of one angle is 1781 of 10 80 by 80 by 2, 1781 into 2. So you have the answer 3562 mm square. Step 2, connections. For HSFG bolts, 10.9 means HSFG. For HSFG bolt, it is also called as non-slip. Both mean the same. Non-slip bolts, M20, property class 10.1. For this you have to refer to clause 10.4.3, page 76. For HSFG equations are given there. For that consider mu slip factor as 0.55. Ne number of interface. Now just let me draw a small diagram. There are two angles. Say this is one plate or gusset plate. For this gusset plate, there are two angles like this, and for this you are going to provide bolting like this across the bolt. So here there is one interface, second interface, therefore Ne is equal to 2. Now KH hole clearance 1.0. I have capital F naught proof load is equal to ANB, area of bolt at threads, into 0.7 FUB. Now ANB is area at threads, and that is given by 0.78 pi by 4 d square. So you have 245 mm square. FUB, ultimate stress in bolts. For this refer to table 1, page 13. So you have the value FUB is equal to 1000 mm square. So capital F naught is equal to ANB into capital F naught, 0.7 into FUB. So you have the answer 171.5 kilonewtons. That is capital F naught. Therefore nominal shear strength of HSFG bolt VNSF is equal to mu F into NE into KH into capital F naught. So substitute the values. 0.55 into NE is 2, KH is 1 into 171.5 into 10 raised to 3. So you have the answer 188, or you can take only 171, 188.68 kilonewtons, that is nominal. Design shear strength is equal to VNSF divided by 1.25. So you have the answer 188.6 divided by 1.25, 150.9 kilonewtons. That is the strength of the bolt. So bolt value is 150.9 kilonewtons. Next, number of bolts required is equal to total load. So total load is 188.68, sorry, total load is 600 kilonewtons divided by 150.9. So you have the answer 3.97. Say 4 bolts. Now edge distance E is equal to 1.7 d naught, so you can round it off that to 40 mm. Pitch distance P is equal to 2.5 d, so you can make that as 50 mm. Now this is the diagram of the connection. This is the in between gusset plate, 2 angles. So for these 2 angles, let this outstanding leg is B is equal to 80. This is the connected leg. For connected leg, A is equal to 80. Now let us put 4 number of bolts here. 1, 2, 3, 4. After that there is plate. Now put the distances. So distances here are bolt center, hole center, edge and pitch, edge is 40, pitch is 50. This distance from this bolt end to this bolt end bolts is LC. This distance from this bolt to start of the plate, LV. Now from this bolt center to this bottom edge is C value, and that you get from SP6. C value is 45. Then this distance is LT. Therefore I am having the equation LT is equal to this distance from here to here, this is 80. 80 minus C. So 80 minus 45, you have 35 mm. So this is the detailing of the joint. Now third step, strength calculations. First is yield strength, TDG AG Fy by gamma m naught. So AG provided is 3562, Fy 250 divided by 1.1. So you have 809.5 kilonewtons. Actually 809.5 into 10 raised to 3 newtons, or 809.5 kilonewtons, and this is greater than 600 kilonewtons. Hence okay. Second, rupture strength. Rupture strength. So for this refer to clause 8.3.3, page 33. Now if you look at the diagram, now this is the diagram. Outstanding leg distance W, W1 is nothing but C value. This is LT. So write down the values. So W is equal to outstanding leg 80 mm, W1 is equal to C is equal to 45 mm. Then thickness T is 12 mm. Bs equation is given in the code. Bs is equal to W plus W1 minus T. So that is 80 plus 45 minus 12. So this gives the value 113. Fy yield stress 250 MPa. Fu ultimate stress 410 MPa. LC center to center distance between farthest bolts. Here this distance from this bolt center, and that is nothing but 150 plus 150 plus 150. So LC is equal to 3 into 150, 3 into 50, 150 mm. Next, beta is given by equation. Beta is equal to 1.4 minus 0.076 W by T, Fy by Fu, Bs by LC. This should be less than or equal to Fu into gamma m naught divided by Fy into gamma ml, and this should be greater than 0.7. So substituting all the values, you get the value beta is equal to 1.17, which is less than 1.44 and greater than 0.7. Hence beta is okay. Now if you look at the equation for TDN, here you need to calculate ANC and AGO. So let us calculate these two terms. So ANC, A is area, N is net, C is connected. So net area of connected leg. Net means you have to subtract the bolt values, bolt diameter. So connected leg is 80, A minus D naught minus T by 2 into T. So A is 80 minus, if you look at this diagram, so this is the connected leg. So I want to find area at this section. So area at this section is this plus this. So I have to subtract this bolt whole dia. That is why D minus 80 minus D naught by 80 minus D naught. So D naught is 22 because 20 is bolt dia. D naught is 22 minus T by 2, 12 by 2 into 12. So substituting the values, you get 629 mm square. Next, AGO. So AGO stands for, G is gross, O is outstanding. Gross area of outstanding leg. So outstanding leg is B minus T by 2. Gross means you should not subtract bolt dia into T. So 80 minus 12 by 2 into 12. You have the answer 888 mm square. Now I have the equation for TDN. This equation 0.9 ANC Fu by gamma ml plus beta AGO plus Fy into gamma m naught. So substitute all the values. 0.9 into ANC 624, Fu 410 divided by 1.25 gamma ml plus beta 1.17 into AGO 888 into Fy 250 divided by 1.1. Now remember, here there are two angles, hence multiply by 2. This multiplication of 2, it is because of two angles. So substituting all the values, you have the answer 840.6 kilonewtons, which is greater than 600 kilonewtons. Hence okay. Now third strength, block shear strength. So LV is equal to, here look at this value, this is LV. So LV is distance of this bolt to this end. So 50 plus 50 plus 50 plus 40, 190. So that is given by 40 plus 50 into 3. So you have the answer 190 mm. LT, length in tension, that is nothing but connected leg out minus C. C is 45. So you have the answer 35 mm. Next, AVG. A is area, V is shear means parallel, G is gross. Area parallel to load, that is gross area. Gross area parallel to load, and that is given by LV into T. So LV is 190 into 12. So you have the answer 2280 mm square. Next, AVN. V is parallel, N is net. Net area parallel to load. Net means you have to subtract bolt value. LV minus, look at the diagram here. This direction is parallel to load because load is here in this direction. From here to here, this is LV, because this much block may fail as block shear. So this LV minus 1, 2, 3, 3 full bolts and half of this, only this much. So 3.5 D naught. So LV minus 3.5 D naught into T. So you have the answer 190 minus 3.5. D naught is 22 into T thickness 12. So you get the answer AVN as 1356 mm square. Next, ATG. T is tension perpendicular to load, G is gross. Gross area perpendicular to load means this area from here to here, bolt center to here, this area, and that is nothing but LT. LT into T is equal to LT into T. So LT is 35 into T is 12, 420 mm square. Next, ATN. T is tension means perpendicular, N is net. Net area perpendicular to load. So net area means you have to subtract bolt. LT minus, here in this direction full bolt is there, of that half is considered here. So D naught by 2. LT minus D naught by 2 into T. So LT is 35 minus D naught. D naught is 0.5 into 22 into T. T is 12. So substituting all the values, you get 288 mm square. Now let us write the equations for TDB. So TDB1 and TDB2. So you have the equations. So this is the equation AVG into Fy root 3 gamma m naught plus 0.9 ATN Fu by gamma ml. So substitute the values, 2280 into 250 divided by root 3 into gamma L m naught 1.1 plus 0.9 into ATN. ATN is 288 into Fu 410 divided by gamma ml 1.25. Substituting all the values, you get TDB1 as 768 kilonewtons, and this is greater than 600, hence okay. Next, TDB2 0.9 AVN Fu by root 3 gamma ml. So 0.9 into AVN 1356 into Fu. Fu is 410 divided by root 3 into gamma ml 1.25 plus ATG into Fu. ATG is 420, Fu is 250, sorry, Fy is 250 divided by 1.1. So substituting all the values you get 653 kilonewtons. This is greater than 600, hence okay. All three checks are okay, hence provide 2 ISA 80 by 80 by 6 with 4 bolts of M20 property class 10.1. This is the design output. This completes the problem. Thank you.